All right, so what we have here, it's parametric equations. Now, when we talk about physics, we talked about yesterday that we learned about projectile motion in physics. When you throw something, we have to split it into the x component and y component. Okay, and here we have the two equations, and these two equations will be given on the quiz this coming Friday. Okay, these two equations will be given this coming Friday, so you don't have to memorize these two. Now, the only thing that's different is that the -16 part, because this is an English system in feet per second, so it's -16. I believe the number is different when you do it in the metric system. I think, what's that number? 4 point, wait, hold on. Forgot that equation. Anyways, so you have V0 cosine theta, V0 sine theta. What are those? Now, next to the box, I would like you to draw something really quickly, and that is this. This is your V0, and this is your theta. Okay, so that would be your initial velocity. Okay, when you kick something, when you hit something, when you throw something, all right, that you are throwing it in a direction, all right, at a particular velocity. And we say, all right, yeah, we have this V0 thing. It is not strictly X nor strictly Y direction. Well, guess what? We have to split it. And split how? We'll say, well, yeah, we're going to split it to Vx and Vy. Well, how do we get Vx and Vy? Well, just like how you do the unit circle value, how do you get your X value? Well, hypotenuse times cosine theta, that's your X value. And then your Y value will be your hypotenuse times sine theta. Okay, so we split the initial velocity into the two components, the X and the Y, Vx and Vy, Vx and Vy, and that's how we have V0 cosine theta for Vx and V0 sine theta for Vy. Good. Where these things come from. Okay. Now that you're good with knowing how we're doing these little physics, and if you're taking the AP physics exam, you should know this very well. Should. So now, what we're about to do is to look at the example and see how we place the values into our equation. It's very straightforward. All right, nothing strange, nothing too complicated. So you have Kevin. Kevin hits the baseball at 3 feet above the ground. And then with an initial speed, that's your V0. And then with theta of 18 degrees with the horizontal, we say, write the parametric equation, please. Okay. And we say, sure. Let's go ahead and write down the parametric equation. So we have x equals to, well, V0 is 150 cosine of 18 degrees times t. Okay, so that's how you input your equation into the calculator in just a moment. And then the y equation would be minus 16t squared plus 150 cosine of 18 degrees times time. Don't forget the time. And then plus 3. Okay. So if I want to draw a diagram to illustrate what's going on here, this is the ground. So this is the ball at 3 feet, and it's going to get hit at an angle of 18 degrees at a speed of 150 feet per second. So that's a little diagram to show you what's happening, okay, to the baseball. Yes? Oh, yeah, it's sine theta. Why did I do that? It is sine theta. Sorry. Yep, it is sine theta. All right. So now, how are we going to put it into your calculator? All right, now go to your calculator. Okay. So when you turn on the calculator, you will go to graph on the scratch pad. Okay, so you click B for the graph, and then you go to menu. You go to menu, and then you go to choice number 3, option number 3, which is graph entry / edit. And then you would choose, well, we're doing parametric, right? So you would choose the parametric equation, that option. Okay. And if you have one equation there already inputted, then you can just clean it. Okay. And you would type the equation. Okay. Type the equation we just had. So x would be 150 cosine of 18 degrees times t. Now make sure you put in t, not x, because this is x in terms of t. Okay. And then the y equation would be negative 16 t squared. And then plus 150 sine of 18 degrees times t. And then plus 3. Okay. So this is what you would type, making sure that everyone can get to the same page. Okay, so you hit enter. So you will see a graph like this. Now, actually, the graph shouldn't look like this. That's not how a baseball travels over time. So, so what happened was that my calculator was in radian mode, so I need to change it back to degrees because the angle that I typed in was in degrees. And you may have something like this. That's not your entire projectile motion. So what you do, you would go to Windows, and then you go to Windows setting. So basically, you have to adjust your windows. And I would say you can be more aggressive initially. Just say X max is 1,000 and Y max is 100, just to see if you can capture the essence of the graph. And we say, oh yeah, now we can see the entire projectile motion. And let's go ahead and readjust the size so that it fits better. So I would say maybe I would like to half the y-axis value and half the x-axis value. So I'm going to do the Windows setting again. Instead of 1,000, I'm going to do 500. Instead of 100, I'm going to do 50. Okay, and I'm like, okay, I'm pretty happy with my graph like this. So that's what you will draw on your graph. Okay, so again, your graph may not look very nice at the beginning. Take control of the Windows setting. Okay, be aggressive at the very beginning because you want to see the entire curve. So make sure that it's big enough, okay, so that you can see the entire curve, and then you can adjust it down afterwards. Okay, so I'm going to draw the graph. So it starts from 3, and then it's going to hit right here. Okay. All right. So that's how you input your input your equations to the calculator.